All right, so after all of this reading, what they want us to do is find the mass of the solid. All right. To get the mass of solid, you will need the partition coefficient. So if you look at the question, the partition coefficient, it was not given, so we need to find it. All right. So let's look at the question. It says when butane dioic acid was shaken with a mixture of water and ether, 10 cm cube of the water contained 0.854 gram of the acid, while a similar volume of the ether contained 0.159 gram. So what are they telling us? You have your separating funnel, you have the two layers. Down here you have the water, above it you have the ether, and the volume of each of them is 10 cm cube. All right. In the water layer, you have 0.854 grams. And in the ether layer, you have 0.159 gram. All right. So if you want the partition coefficient, you just work out the mass concentration. So I'm going to call this, all right, so I'm going to call it Y, all right, so to keep it simple, all right, so the concentration of Y in ether would be equal to 0.159 divided by 10, and that would give me 0.0159. The concentration of Y in water, that would be equal to 0.854 divided by 10. That would give me 0.0854. Oh, mass of acid, thank you. And so this should be acid, not solid. So now that we have the concentration of ether and water, let us see which one should go on top. So butane dioic acid, all right, so when this was shaken with a mixture of water and ether, 10 cm cube of the water contained 0.854, and the acid in the ether contained 0.159. Based on these numbers, the acid is more soluble in which one?
Water, sir.
Right. And so which one would we put on top?
0.854.
Right. So it would be the 0.0854 divided by 0.0159, and you should get 5.37. So the only mistake you can make here is putting the wrong thing at the top.
Excuse me, sir.
Yeah.
What did you say about how to determine which one is to go at the top again?
The one that is more the solvent that the solute is more soluble in.
So, sir, is this a case of what the bigger number, the higher
Right.
value number goes on top?
Wait, so when you look at the question, 0.854 gram of the acid dissolved in 10 cm cube of water, and only 0.159 dissolved in the ether. So this is telling us that it is more soluble in the water because a larger amount dissolved in the same volume. Understand?
Yes, sir.
Yeah.
So, sir, you didn't answer my question. So the amount that has the greater volume ratio is the one that's the numerator?
Yeah, because that would mean it is more soluble. So what was done to the right hand side? All right, so remember in calculating KPC, it is the concentration that we are using. So in the question, it gave you the mass and the volume. So we have to calculate the mass concentration. So over here, we calculated the mass concentration. Gram divided by cm cube, gram per cm cube, that's mass concentration. All right, so so your first thing I do is calculate KPC. All right, I'm going to erase the question now because we haven't actually answered the question as yet. So the first part of the question was to allow us to get KPC, the solubility. All right, so remember we said that this would be equal to the concentration of the acid. I'm just calling it Y, so I don't have to write out the entire word. So it is Y in water divided by Y in ether. All right. Now it says in a separate experiment. So let's look. In a separate experiment, 10 cm cube of water and 20 cm cube of ether were shaken together with 1 gram of the acid. So 10 cm cube water, 20 cm cube ether was shaken together with 1 gram of the acid. And they want us to calculate the mass of acid found in the aqueous layer. All right. So these are the two types of question. Either calculating KPC or mass. This is what you're going to do, right? So remember now, concentration is mass over volume. We don't know the exact mass of water because, I mean, the exact mass of the acid in water or the ether, because all they said they mix it with 1 gram. And remember, it would have been distributed, but we don't know how much in this particular experiment. All right. So for the mass of the water, so remember now we have KPC. So what you're going to do, right? For this calculation, we're going to use X to represent the mass of water. All right. So the mass of so X are the mass of the solute in the water. Let me say it properly. All right. The volume of water from the experiment is 10. All right. Look at the equation here. We have the concentration. This is the concentration divided by the the amount in the other layer. So you start out with 1 gram of the, let me use a different color. 1 gram of the solid. Based on how much goes in there, in the water, it will decrease by that amount. So it is going to be 1 gram minus X. Remember, we don't know the exact mass, so we're using X to represent it. So it is X divided by 10, right? This part is working out concentration. Remember, this is mass, right? So mass over volume, that would be the mass concentration. So it's mass concentration divided by mass concentration. So X over 10 here, that is mass concentration. 1 minus X would be finding the mass remaining in the other layer. All right, so 1 minus X here, that is mass. And they are dividing it by volume, which is 10. All right, wait, not 10, 20. So for this calculation, right, you're going to start out with a lot of lines. So I'm just explaining it. Let's go back over here, right? When I want to find the partition coefficient, it's the concentration in a particular layer divided by the concentration in the next layer. Remember, concentration, remember, mass concentration is mass divided by volume. That is why you have X over 10, the possible mass in water over the volume, divided by, right, the possible mass in the ether over the volume. All right. So KPC would equal to all of this here.
Sir, there's something I don't quite understand. Why is it that for the 20 centimeter of a ether for that side for the mass concentration it was subtracted by 1, but for the mass concentration with the water at the numerator it remains the same.
All right. So remember we said that we're using X to represent what? Quickly.
The mass
Of?
of the concentration in the water and
Right. So if you have 1 gram, right, and you're using X to represent the amount in water. So let's say X was 0.5 gram. That means to get the amount in the other layer, you would have to subtract 0.5 grams, right? Yes, no, quickly.
Yes, sir. Yes,
All
sir.
right. Yeah, so that is why you have X there. And that is why we have to subtract X here. So any amount that is in the water layer, you are subtracting it from the total mass. So that is why it is 1 minus X.
Oh,
So,
I understand. So it's basically to equalize the amount of the unknown X amount in each liquid.
right. All right, so let us make this a little simpler now. All right. So what I want you to do, right? Don't pay attention to KPC as yet. So what do we have here? We have X over 10, right? So I want you to do it like this. Or if you have a next way that is easier, no problem. All right. So you have X over 10. So X over 10, right? You have your division line. So x over 10 divided by 1 minus x divided by 20. All right. So just like with fraction, x over 10 times 20 divided by 1 minus x. Everybody clear at this point?
Yes, sir.
All right. So you can do two things at this point, right? 10 can go into 10 one times. 10 can go into 20 two times, right? So that would give you what? 2x divided by 1 minus x. Let me know if you're still following.
Yes, sir.
Following.
X. So look, 10 into 10 goes 1 times, 10 into 20 goes 2 times. So instead of saying 20x over 10 times 1 minus x, you just simplify these two numbers here. 10 into 10, 1, 10 into 20, 2 times. All right, let me just check if everybody is on the same page. All right. So at this point now, remember KP is equal to all of this, right? But all of this has come down to what? 2x divided by 1 minus x, right? What was KP again? What did we get it to be? 5.37?
Yes, sir.
Right. So now, right. So now you can say 5.37 is equal to 2x over 1 minus x, right?
Yes, sir.
Let us cross multiply. So we're going to bring 2x on this side, all right? And we're going to bring 5.37 to this side. The 5.37, it is going to multiply the 1, and it is going to multiply the x. So you're going to get 5.37 times 1, 5.37. Take away 5.37 times x, 5.37x. All right. Once I reach here now, we're basically almost finished. We're going to bring over the 5.37 to this side. It was minus. When you carry it over the equal sign, we're going to add it. So it would be 2x plus 5.37x is equal to 5.37. All right. So now if you add up these, you would get 7.37x equal 5.37. So we are trying to find x. So we're going to divide both sides of the equation by this. So x would be equal to, let me see what I got, 0.73.
Sir,
Yeah,
I don't mean to slow down the process or anything,
yeah.
but like in the chat and stuff, and for myself too, a lot of us kind of got a little bit confused when the numbers started coming and so like if you could just, I forgot in depth all over again, but if you could just,
All right, let's do it again.
Yes, please. Thank
All
you.
right. So come back over to the left-hand side over here, right? All we're doing is dividing two sets of concentration, right? But it's just that we don't have a number for the concentration. So it's not like 0.5 over 0.8. Somebody's mic is on. All right. So x over 10, right? You just put that by itself, and the 1 minus x over 20, put that by itself. Because what we're doing is dividing all of this. You're dividing all of this by all of this, right? So it's x over 10 divided by 1 minus x over 20. So you just switch out this line here for the division sign. So
So
remember,
why you minusing one again?
so this is the mass, right? And x is the mass of the solute in water. So if you want to know the mass in the ether, so remember the question work a while ago? You have 10 gram and 1.36 was in the water. So we subtract 1.36 from the 10 gram. Remember this question a while ago? And we got 8.34, right? So it's the same thing here. It would be like 10 gram minus 1.36.
Oh, okay.
Yeah, so X is the mass of the water, the mass of the solute in the water. But remember, we don't know what the mass of it is. That is why we are just using X to represent it. Understand?
Yes, sir. Thank you.
All right. So we're dividing X over 10 by 1 minus X over 20. So remember, a little fraction, if you have 1 over 4 divided by, let's say, 2 over 5, it becomes what? 1 over 4 times 5 over 2, right? Hope you remember that. Right, so that is why it's now x over 10 times 20 over 1 minus x. So we flip this side. So this changes to multiplication, and this part of it, you flip it. All right. So once you do that now, if these two have any numbers in common, you can simplify it. All right. So what I did, 10 can go into 10 one time, 10 can go into 20 two times. Then I just multiply the top. So 2 times x, that is 2x. So what I'm left with is 2x divided by 1 minus x. All right. Just bear in mind that Kp is on this side of the equal sign. So basically I was working out the right-hand side of our equal sign. So 2x over 1 minus x, that is the right-hand side of our equal sign. Kp is on the left-hand side. So the 5.37 now, I am introducing Kp. So 5.37, let me just put it over 1 if you want it as better. So 5.37 over 1 is the same thing as 5.37, right? So once you reach this part, you cross multiply. You bring 2x to the left-hand side, and you bring this over to the right-hand side. But you have to multiply it by whatever number is here, and you have to multiply it by x. So 5.37 times 1, I write it down, put back the minus sign, you times it by x again. All right, so that will be it. And then all you have to do now is carry all of this across the equal sign. But because it was negative, when it come across the equal sign, it becomes positive. All right. And then you just add them up. So 5.372, 7.37. You want x. So whatever number is here in any future question, you divide it by 7.37. All right. And whatever you do to one side of an equation, you also have to do it to the next side. So we divide both sides by whatever number is over here. All right, so we have to move on again. It's 1 hour already. We are moving to polymers. So remember, this question was from 2013. The previous one was from 2012. In most cases, water would be below, but not all the time. All right? So you have to pay attention to the question. Let me say this, in the separating funnel, water is denser than your organic solvent. All right? Water is always below, but in your equation, that is not what we are looking at. All right? So just read the question carefully. All right? But as I told you, whichever is more soluble. All right, so we have to move on. This question is like 5 marks. So if